All right, after that trauma in chapter 7, 8.1, 8.2, chapter 8 gives us some ease before Christmas. We welcome chapter 8. Remember exponential functions from grade 11, not that difficult, especially when we talk about transformations. The logarithmic function is just the inverse of an exponential function. So we have y equals a to the x, where a is the base, and the inverse is x equals a to the y. We switch x and y. It's a reflection in the y equals x line. Here we have y equals a to the x. We reflect it, so all the x's and y's switch, and we have x equals a to the y, but the way we write that, y in terms of x, needs to use the logarithmic function. So log base a to the x. And that's what this function is. It log base a to the x. This right here, I'm going to cloud it in red, is probably the most important thing in this lesson. You need to know that, because when you see a log for the first week, you might not know really what it means, and you need to be able to convert it back into exponential so you can kind of recognize it, because we've dealt with exponentials our whole life. So when you see a log function, you say a to the y equals x. And if you can do that, you kind of understand where this is going to go. Notice that when a is greater than 1, both functions are increasing. So when my base is greater than 1, it means it's growth. 2 to the x, 3 to the x, 4 to the x, it gets bigger and bigger and bigger. And likewise, this is also increasing. They're both increasing. But if it's less than 1, like a half or a quarter, it's going to decrease the exponential function. So both functions will actually decrease. Okay, when we graph, we actually only graph log base 10. We don't graph the exponential function 2 to the x, 3 to the x. It's just 10 to the x, the inverse. So log base 10 to the x. Okay, so biggest thing to take from here is definitely that translation, I guess you can call it. Now in 8.2, it's all old stuff. We've done transformations. Let me draw your attention right here to this equation that we've used year after year for every function. We have our a value, our k value, our d value, our c value, and we have a new function, log. That's it. As long as you know how to graph log, you can graph any transformation of log. Okay, remember this formula as well. How do we use these translations and transformations? Well, we have to divide x by k and add d. We have to multiply y times a and add c. We already know this. So let's put it to use quickly. We want to use transformations to graph y equals -2 log x minus 4. Notice that there's no base here. When there's no base, it's always assumed to be a 10. Okay? So generally when we're doing log base 10, we don't write the 10. So it's assumed to be a 10. You can see on your calculator, the log button is log base 10. We also want to state the domain and range after. Okay, so I gotta multiply all my y values by -2. I'm gonna do that first. I'm gonna separate it. So this is my log base 10x. If you wanna know how to graph it, it's just 10 to the what? 10 to the 1 is 10. 10 to the 2 is 100. Okay, notice how I'm using the y value as my exponent though. The y value as my exponent. It's kind of backwards from everything we've done. Okay, so I'm going to take this y value and multiply it by -2, and it moves down here. I just picked a random point, 32, 1.5, so 10 to the 1.5 is 32. You really don't need that point, but there's too much empty space here, so I just picked one there. Times 1.5 is -3. And times -2 is -4. And I have my new transformed function, but this is just y equals -2 log x. Again, don't have to put that 10. Notice how this point is also the same because 10 to the 0 is 1. So that point is always in common. I made sure I wrote those ones over here because 1 is a pretty good key point for log and exponential functions. Where's my blue marker? Okay, so now I'm going to move 4 units to the right. The scale is 10, so 4 is kind of annoying, but no problem. I'm going to move 4 to the right, 4 to the right. And I'm going to graph my new function. This is going to be y equals -2 log of x minus 4. And that's my final answer. Okay, not much difference because of the scale, but it is shifted horizontally 4 units. Okay, so the only thing that you should be kind of like, what's going on here, is with this log base 10 to the x. That's it. Once you know how to graph log base 10 to the x, probably take you 3 minutes to figure that one out. Everything else is status quo from previous years. And likewise, in previous years, you also, oh wait, domain and range, before I forget. Now, domain of an exponential function, this blue one, we always knew was XER, right? And we just needed to find out where that horizontal asymptote was to see if it's above or below the horizontal asymptote. Now it's the opposite. Now our domain is restricted based on this vertical asymptote. So our vertical asymptote here used to be at 0, and now it's 4 units to the right. So my domain is XER, but x has to be greater than 4. Okay, so it was 0, my vertical asymptote, but I shifted 4 units to the right, and now it's at +4. And my range of every logarithmic function is just YER. It's the reverse of an exponential function. Okay, now using words, we want to come up with an equation using geometric description or any description. We have a regular base 10 function, and it's been vertically compressed by 2/3. So vertically compressed by 2/3 is our a value. We put a 2/3 in front of the function. Horizontally stretched by a factor of 4. Be careful with the k value. If it's horizontally stretched by 4, the k value must be 1/4. And then reflected in the y-axis. Reflected in the y-axis has to do with the x values, so the k value, negative. Next, it is also horizontally translated so that the vertical asymptote, which starts at 0, is now -2. So it's not x equals 0, it's x equals -2. So it's shifted that way 2 units to the left. What do I use for these? This. So to the left, if the d value is -2 and I plug it into the equation that has a negative, it's +2. Next, I have to move 3 units down. That's an easy one, probably the easiest. And done. I've just transformed a logarithmic function. If I have to graph this, just graph log base 10 to the x and apply these transformations. Right? Make sure we do the multipliers first and then the adding and subtraction ones. Okay? Remember this formula? I don't really use this formula too often, but it could come in handy in certain scenarios. Okay? You still have to know it. I still know it. Maybe I use it 5 to 10% of the time. Okay? But some people graph everything using this formula. You do you. Okay? So that's it. That's logarithmic functions.